Hello everyone, welcome back to another video on Vedic astrology. For an astrologer, the fundamental knowledge about astronomy is a must. Hence, I constantly tell my students that they should learn the fundamentals of astronomy. For those who are already taken my fundamental Vedic astrology course in Udemy, you should be already aware of some of the fundamental astronomy concepts. For others, this is going to be a wonderful introduction session on astronomy. My beloved friend and student Mr. Manikandan consolidated some of the important astronomical concepts that are required for an astrologer. Let us hear from Mr. Manikandan.
So these are just my understanding about astronomy and astrology and how I look at these two different subjects and what are the similarities that I see in these two. Going forward, so this is how I see the three related. So we have astronomy and we have astrology, and both have similarities and also kind of each one is separate, and also they both have their own set of ambiguities. So our entire process or challenge is to kind of remove the ambiguity and try to see what is the relation between astronomy and astrology. At least that's what I was planning to do, or I'm still doing it. Okay. Going forward, so any study on astronomy or astrology, we have to understand what is the real reason for our ancestors studying both astrology and astronomy. So it all started off with measuring of time. So why we need to measure time? So there are different reasons why our ancestors thought it will be advantageous for them to measure time. First is to predict weather, when it will rain or when the wind will blow or when it will flood the rivers. The other reason could be agriculture. So when to sow the crops and when to harvest, when is the time the weeds or will grow, and the sun is bright and shining. The other advantage about measuring time is hunting. So if there is a particular time the wild animals are kind of outside, so we need to understand when is the safe time to travel or move outside their caves or their living place. And later when we started going around the globe, we also have to understand how the winds are blowing so that ships can travel. So that is also measuring time or understanding time is kind of very crucial in that. And then probably on the safety side, so if you are traveling outside your safe place and then you want to know like how long you will be out and how long, like what is the time it is left for you to return back to the safe place. From a health perspective also, if say some medicines you are taking, then we need to understand how long will it take, will it be required to take into effect, or if some poison or some insect bite happen, how long is the time that we require to kind of get it cured. So lastly, and we also were kind of using time to do the predictions. So we need to know which is a good time to start an activity, or where what are the times we should avoid starting some activities.
So last few are like coming to the astrology, right?
Yeah. So there's also it is like everything is kind of tried, or ancestors tried to do something for the benefit of the humanity. So all these things are kind of interrelated, and that's how I see it.
Right.
Next is so they said that they decided that they have to measure time. Then they have to come up with a kind of a methodology on how to measure time. So there are different ways that they use to measure time. So one is reducing gravity, which is a kind of a very simplistic method where you can measure time by the amount of like time that water drips from uh, a pot. and based on the volume, and they can easily identify like how much time it takes for the pot to be emptied. So, and then there is a pendulum where it kind of swings based on gravity, and also sand flow. So you have the sand dunes, and then you can easily measure how much time it takes for it all the sand to flow down. The other way they are trying to measure time is based on the location of the sun or the moon, or the time when the eclipse happens. So the pictures, as you can see, there is a linga. On top of it, we have the pot with the water dripping on it. So maybe that could be a time measuring instrument where I always see there is a correlation between religion and science. And this is something which I see that there is a possibility that it could be a measurement of time. And I also see you can see the gopuras of, this is the Travancore temple. So you can see that the gopura, the sun kind of goes down into the different levels. So when you see from the temple, so we can see that based on the location of the sun, we'll be able to identify what time it is or which month it is.
Mani, can you go to the full screen mode, like the presentation?
Yeah.
I think this temple, on the day of equinox, I think it will pass through all the poles, I think. Right. This temple is in, yeah, it's in Kerala, I guess.
Yeah, this is a Trivandrum temple.
Trivandrum, oh, yeah, okay.
So that's also, I see that there is always a science behind all the religious activities. Only thing is that we have not fully understood what it meant actually. There is even like these devices where we, based on the shadow, where it falls, will be able to predict the time on the day.
We have that in our college, right?
Yeah. Yeah. So these are some kind of ways the ancestors would have measured time, and maybe took advantage of measuring time.
Probably what I think, right? The first, it might have started with sun, moon, and eclipse. Then probably to measure it in absolute form, they might have used other techniques, whatever you explained, right? Water dripping, pendulum, sand flow. But I think ideally it should have started with planetary motion.
Yeah, planetary motion is for a longer duration of time, whereas this water dripping are for a smaller duration, like hours and seconds.
Yeah, that's right.
Yeah. So going forward, so these are the different time scales. So the Western, they usually measure it in years, months, days, hours, and seconds.
I think Mani, your slide is not moving. Still, it is in the fourth slide.
I don't know. Maybe it is not sharing.
Oh, now it has moved. Yeah, now it has moved.
Okay.
Right.
Okay. So the different time scales for the Western world, they usually measure it in years, months, and hours and seconds. Whereas in Indian time scale, in South India, we measure it using Naligai and Vinaligai. And I was kind of curious to see like what are the different ways that they could have measured the Naligai or Vinaligai. So we saw that with a longer duration, we can measure it using the sun, moon, and the eclipse. Whereas the shorter duration, it should be based on the like the beats that they usually use to rotate, or based on the musical instruments. When you play a song, it kind of has to follow a rhythm, and that rhythm, how long the song plays out. So based on that, you can calculate how many duration that it has been spent. Or even the Vedas, the slokas are written in a particular time scale. So if you recite this many slokas, then this much time would have happened. So that is something like I see as a way of measuring time on a shorter scale. Next one is how it is correlated to astronomy. So they can measure longer durations of time using the visible objects in the sky. So when you say the ones that objects, solar, objects in the sky that we can see with our naked eyes are the sun, the moon, Mercury, Venus, Mars, Jupiter, Saturn, and the constellations. So these are the predominant kind of things that you can see in the universe, in the sky, and that will be able to use for our tracking of time or movement of celestial bodies in the sky.
Okay.
When we go to the Earth's rotation, so we see that the Earth's axis around the rotation around the sun is shown here. So it's an elliptical orbit. So the farthest from the sun is around 152 million kilometers, and the shortest distance is around 147. So it's close to a circle, but not exactly a circle. And then we have this equinox line and the solstice line. So we have the Earth's axis being tilted by 23.5 degrees. So that is the reason we have this four different seasons for the northern hemisphere and the southern hemisphere differently. So as you can see, like this is we are in January now, so it is kind of tilted towards the sun. The southern hemisphere is seeing the sun, so we have the summer here in Australia, whereas the northern hemisphere, which is US and even India, is experiencing its winter now. So the exact opposite happens when we come around July, where we are experiencing the peak of winter here, whereas the summer will be at its peak in the northern hemisphere. So going further, so this is the shows the tilt of the Earth's on its axis, so facing the sun. So you can see that at the poles we have seen that the Earth is around 23.5 degrees at an angle to the sun, whereas at the equator line we have around 66.5, and at the Tropic of Capricorn we have at around 43 degrees. So the sun kind of because of the rotation of the Earth around the sun, we get this Earth moving, the sun moving from Tropic of Cancer to Capricorn, and from Capricorn to the Cancer. So that is the movement of the Earth when it moves around the sun. Moving forward, this is a very good chart showing the difference between the geocentric and heliocentric models. So as you know, we'll start with the heliocentric, which is the most conventional way of looking at the solar system. So in the heliocentric, we have the sun at the center, and then we have all the planets revolving around it, and then we have the Earth with the moon revolving around it. Whereas if we look from the Earth, keep the Earth as a center, and then we look outwards and see how the planets move around. So then we see the planets move in this kind of form, where the sun is kind of going in the same circle around the Earth, and moon is also doing a circle around the Earth. Whereas the other planets have itself is circling the Earth, but it also has its own retrospective movements as well.
Okay. Hey, anybody have any doubts? Please stop him in case.
Yeah, this I've always had trouble imagining when the Earth is in the center. Like for example, if you check the red line,
Yeah.
I'm not able to visualize this because in the
Yeah. I
heliocentris.
have I have the slides showing that one. I have even the video of that. I will show you that.
Okay, because in the helio, the red line is very close to Earth, but then in geo it's so far away. So that's why I don't get it. But I understand the logic, but I can't visualize it.
Yeah, I have. There is a kind of video in I think Wikipedia. I can show that one.
Okay.
Just shows how it kind of looks from looking from the Earth, like how it be. It's seeing that it's going backward,
What's
whereas
the red line, Mani?
red is Mars.
Okay.
Red is Mars, green is Jupiter, and the blue is Saturn.
Okay.
So we see that the Earth is blue, and we have the white moon rotating around the Earth. But if we keep Earth as a center, then we see that the moon is the first one that is closest to the Earth, which is rotating. Then we kind of take it out. So, like if you see that, then how frequently the Mercury, at least from a viewpoint, look is it's rotating around the Earth. So it kind of rotates around the sun, but it kind of goes it in a circle. So we see that takes a longer time to rotate around the Earth.
Yeah. But it's still hard for me to see it, but I get what you're saying. Thank you.
And this is how we see the Earth. Say all our charts, everything is based on the geocentric point of view. So our charts, everything will reflect the geocentric, whereas both are the same. So we are just a different representation of the same actual happenings of the universe.
Right.
So people say that it is a wrong model, that the geocentric is not the correct one. It's a kind of a superstition. But the way astrology is kind of created, it is based on a geocentric model or a heliocentric model, but the representation is from a geocentric side.
Right. Yeah.
So anyway, we'll kind of discuss it in detail. So then I kind of see that our ancestors have written a detailed book about Surya Siddhanta, which kind of talks about the sun and how the planets that goes around it. So it was kind of created in BC, third, 4th century or 5th century. It's a Sanskrit text, and it kind of talks about what is the time duration, how much time, how we are measuring time, and what is the time scale that we are measuring. Actually, like if you see that we are measuring. So Gatika is 24 minutes and 2 Gatika is 48 minutes, and then we have in 24 hours how many muhurtas are there. So like we already have a measuring system which is equivalent to a day. So it's a different way how the Westerners think that it is 24 hours is equal to 1 divided in 24 hours is yeah. Also have a different way of measuring the same time duration. So, and also we have a lot of knowledge on how the sun moves around the earth moves around the sun. So we have built a temple. So we know that exact time when the sun's rays will fall on the linga. So this is a temple. I remember it is in Karnataka. Where or no, Yeah, so this is the Jiva Gangadeshwara temple in Karnataka, where on the Mahar Sankranti day, the sun's rays exactly falls on the linga. So this is kind of gives us even more insight into what are the knowledge that our ancestors possessed regarding the movement of Earth, the Sun, and the other planetary objects.
Okay, interesting.
And next is the lunar metrics. So there is two different ways of measuring time. So once we saw that we can measure it by based on the location of the sun and where it is on the where are we on the orbit around the sun. There is another method which is based on the lunar position. So we have the different phases of the moon, and based on that we will be able to identify what day it is or which direction we are moving. So here also we have the 360 days. So this is the lunar calendar, and we have horoscopes based on this as well. So the horoscope study the lunar aspect of the time calculation also. I think that's what we say that the lagna is calculated based on the sun, whereas the rasi or the is calculated based on the moon.
Oh, what is the difference, Mani? How
So
we say Lagna is based on the sun?
So the lagna is the time when on a particular day when the sun rises and how long that sun has moved. So the easternmost location,
Right.
so that is based on the sun movement. Whereas
That's
the
right.
rasi is based on the location where the moon is in the particular constellation. So horoscope is a combination of these two, the sun movement as well as the moon.
Okay. I think that is the reason why the Vimshotre Dasha, even though it is right now we are calculating with respect to sun calendar, ideally it should be calculated with moon calendar, considering 360 days in a year.
Yes.
Because this somewhere I read, and even my father used to tell this, like according to Vimshotre Dasha, for every year we have to reduce 5 days, because for sun year is 365 days, but moon year is 360 days. So if a child is like 40 years, right? So every year it will be 5 days, it will be lesser, right?
Lesser,
So
okay.
by the age of 40, your Vimshotre Dasha will be almost 40 into 5, 200 days lesser actually, like moving forward.
Okay.
So that the buffer we can give, like while making predictions, that buffer you used to give actually.
Okay. Next is on the solar time. So
can you go in presentation book, Mani? Better.
Yeah. Let me stop
Third button
sharing.
after.
I will. No. Once I go to presentation, it is not. It stops moving. So I'll share it with the whole window. You're able to see?
Right. Good.
Okay. So the solar time and the sidereal time is kind of calculated in like a slight difference between the two. One is assume that this is the Earth rotating on its axis, and this is the South Pole, and it is directed towards the Sun, and there is a distant star which is kind of in the same direction. So what happens is when you measure a particular sidereal day, which is the day when we see that the star that we see that it is far away from the Earth, if the south again matches with the same day of the same position of the star, then we call that as the sidereal day. So if the star is so distant, so 1 day of movement of the Earth is not going to be a significant difference in the position of the star. So when the south kind of points towards the star direction, we see that the star is at the same location as the south. So that is why we have the sidereal day is slightly lower than the actual mean solar day. So mean solar day is when the Earth, after going 1 degree, that is after passing 1 day, it actually moved around the sun. And because of that, the actual middle, that is the noon, this is called the mid noon. So it has to travel some more degrees to match the mid noon. So that is the reason the actual mean solar day will have 24 hours, whereas the sidereal day, which is kind of directed based on the location where we see the distant star, that will be 23 hours 56 minutes. So there will be a 4-minute gap between the sidereal day and the solar day. And this 4-minute gap is kind of accumulated over a period of time. And we see that at the end of the end of the once a revolution around the sun, we have that this 4 minute is converted into like a 1 day. So the total mean solar day will be 1 day lesser than the mean sidereal day is 1 day less than the mean solar day. So what it basically want to say is, when we measure the distance based on the distant star, we have a different time calculation. Whereas when we measure it based on the sun, then there is a different, there is a small difference between how we measure the time taken. So because of the relative movement of the Earth, Sun, and distant star. So this adjustment we have to kind of make at the when we see that there is a difference when we accumulate the times over a period of time.
Right. Yeah.
So now we go to the moon's orbit. So this is the 23.5 degree the tilt of the Earth, and moon kind of rotates around the sun, around the Earth, at a degree of 5 degrees difference from the plane of rotation of the Earth. So if you see that, so the maximum declination can be 23.5 plus the 5, so it will be 28.5, and the declination will be again the 28.5. Whereas the minimum when the when the moon rotates in this plane, then it will be 3.5, and then there is the subtraction of 5, so it will become 18.5. So the moon kind of rotates around the sun by changing its plane of rotation at the degree of 5 degrees from the Earth plane of rotation. This is very crucial when we kind of look at how eclipses are formed. And because of this inclination of the Earth and the plane of rotation of the moon inclining with the plane of rotation of the Earth, we have eclipses like not occurring every 15 days. So we have only at a certain point where the intersection of this Earth, Sun, and moon happens, we have the eclipses happen. So, see that in the next picture. So this picture shows the what is the favorable time that an eclipse can happen, and what are the different times when eclipse cannot happen. So if you see here, this is the full moon day where the moon is on the opposite side of the Earth. So Earth is here, and then we have the sun. Whereas the shadow of the sun, Earth is kind of going in this direction, and the shadow of the moon is also going in this direction. Whereas there is no kind of clashing of the shadow of the Earth on the moon, and that is the reason we don't get a kind of a lunar eclipse here. And the same here also. So if you see the moon is here, which is lower to the plane of rotation of the Earth, and because of this, the shadow of the moon misses the Earth. So even though the moon, Earth, and the sun is all in the same axis, the shadow of the moon is not falling on the Earth. But if you go on this direction, if you see the in this plane, when the moon kind of comes and it has a interaction with the comes in between the sun and the Earth, we can see that the moon as a shadow is kind of falls on the surface of the Earth. So we see that there is a lunar, the solar eclipse happening, and there is a on the other side also we have the moon kind of crossing the shadow of the Earth, which kind of falls creates the lunar eclipse. So only in these two conditions we see that there is a possibility of the moon, Earth, and the sun on the same line, and there is a possibility of a eclipse happening. Whereas when the Earth is on this side or the other side, we see that we will not be able to get the eclipse. And this is the node that we are seeing as the Rahu or Ketu. So where the Rahu or it's kind of and Ketu is responsible for the eclipse. That's what we have it in astrology. So this is the nodes, the northern node and the southern node.
So ideally, the sun, moon, and the earth should align in the line of nodes. Then only the eclipse will happen, right?
Correct. So even though it is rotating on the same plane, but it can come here and it will still be in the same line, but the shadow will not fall because the moon is at an angle to the plane of rotation of the Earth.
Right.
It's really beautiful.
Yeah, so it's very like the 5 degree of the rotation of the, like the inclination of the moon's plane of rotation with the plane of rotation of the Earth is what kind of gives us lunar and solar eclipse. Otherwise, if it is on the same plane, then we'll have lunar eclipse and solar eclipse almost 4 times a year.
Yeah.
Is it exactly 2 times a year, or
4 times?
no? 4
I
times.
have the chart next to this.
Okay.
So this is the solar eclipse. This is a total solar eclipse that I am talking about. So this is exact point where we see that the moon is able to fully cover the sun. So we see that there is a pattern that is being followed, like for the last 12 solar eclipses. We see that some happens in 1 year or 1.5 years, or some further later than that. So I think it all depends on the rotation of the moon and the point where it exactly comes and aligns with that node. So I have not done anything more on this, but just wanted to plot and see in like when our ancestors would have looked at it, maybe this is what they would have understood and plotted against, and then seeing there is a pattern of this one. So if the pattern is repeating consistently across multiple years, they will be able to identify when the next solar eclipse will happen.
Mani, what is the first one? 856
days.
What is that? 8.
So these are days. So when the first solar eclipse happens on 8, like on day, then the next solar eclipse will happen 355 days after that.
Oh, okay.
Next solar eclipse happens 502 days after that. So these are the data that I collected from the
okay. You plotted it. Okay.
Yeah, so I just wanted to plot and see, is there any recognizable pattern which kind of follows, because almost the planets and the kind of moon rotates in the same kind of speed, and there is no change in the speed at which it rotates. So it should definitely follow a pattern, and this is how a pattern looks like.
But here we can see a pattern, except for the 680 and
Yeah,
months.
that's right.
Yeah, so 680 also, if you see, it will be a pattern because this is the where the pattern starts and this is the where the pattern ends.
Oh, if you draw one more cycle,
This
okay.
is the middle of the two pattern.
Oh, yes.
So it is symmetrical on either side, so it should be following the same pattern.
Right.
So are you saying this is repetitive? So from 1 to 11 it repeats?
Yes, it should repeat. Yes.
Okay.
That's how I see that this is the data I plotted. I see it should be repeating itself again.
Okay, you did for almost 2012 to 2027.
27, yeah.
Okay.
And that's what I wanted to kind of do this on a planetary calculation and see if, how this is 355 days and why it is 502 days and why it's again 355 days. So that is still kind of pending. It requires a lot of calculation on different locations of the Earth, Sun, Moon. So it's very complicated.
Right.
Initially, I thought it was easy, but it's not so easy. Then kind of wanted to see the lunar eclipse also. So these are like total lunar eclipse and this is total solar eclipse. So the partial lunar eclipse, partial solar eclipse still happen, but I'm not taking that into consideration.
Okay.
So here at least we can see that it is consistently following some pattern. So 2 to 3 days kind of. So we'll get at least one lunar eclipse per year. So at least 2, if that goes.
Okay.
And so going next is the solar system. So these are the different distances from the sun and the distance traveled in one orbit. So that is also listed here. So you can see that the more further we go, the more distance that or time it takes for the planet to go around the sun. So if you see, this is the planets that we are very much concerned about. So for Earth, it takes for a 30-degree movement, that is from one Rashi to the next. So it takes 30 days. So basically the sun moves from one Rashi to the next one in 30 days. Whereas if you see Saturn, it takes 896 days to move from one Rashi to the next. So that is equivalent to our 2.5 years. So these are the like outstanding facts that which they are able to observe when the Saturn moves from one Rashi to the next in 2.5 years. And without any telescope or any modern equipment, they are able to constantly monitor and see when it actually crosses that 30-degree mark. And for one full revolution around the sun, it takes 30 years. So if a person is viewing those planets or on the sky and marks it, and then after 30 years, he sees that the same planet is in the same location. So it needs a continuous measurement of the planet in the sky and also for 30 years of effort to recognize that the planet has come around the sun. So it has to be kind of data which is mapped and kind of transferred across generations so that they are able to identify these patterns and they were able to kind of fine tune their data over a period of time to get to a point where it is predictable to easy to predict what is going to happen, when the solar eclipse is going to come, when the lunar eclipse will happen. So it's really kind of
Hi, Mani.
enormous effort. Yeah.
What does this mean? Like you're saying 30.438 days is the time it takes for 30-degree movement. Is that right?
Yes.
Is
So
this
if you see, this is the chart. So these are the 30 degrees. The 360 degrees is split into 12 30-degree segments.
right?
So for a planet to move from one end of this thing to the next end is a 30-degree movement. So Earth, which is shown in blue here, it takes 30 days to move from here to here. Whereas if you see, this is Saturn, which is from here to here, it takes
So that
896
matches
days.
365 days, and we say 360-degree, and all. So that, like, broad level, it matches number of days Earth takes to go around the sun.
Yes, yes. So this is all scientific data. So we are not kind of correlating or cross-checking with the horoscope or anything. So this is directly taken from the scientific measured data. I just want to kind of put it and see like whether it matches closer to what we account in horoscope. And I think with the what they call the Muthu, what is that called, the astrology name?
Which one?
Kanida.
No, I think I
Forget the
don't.
name. Kanida. Because the previous astrology, they were kind of totally relying on the Veda, the slokas.
Oh, you are asking about Panchangam.
Slokas, and they were kind of tracking it based on the time calculation equations in the slokas, whereas
Right.
now they have upgraded to kind of using the ephemeris.
Correct. Yes. That's the difference is basically the Vakya Panchakam and the Trikanida Panchakam.
Tirukanida. Yeah. So that is where the wanted to kind of see what is the whether we are using the similar kind of data which is scientifically proven.
Okay.
So that's where you see that Saturn, it takes 896.3 days, which is close to 2.5 years of our Saturn moving from one Rashi to the next.
Because I think, both the factors, right? It's very far away, plus the speed is very low for Saturn.
Correct. So the speed also is given here. So if you can see, the speed is 9 kilometers per second, whereas Earth rotates around 29 kilometers per second.
So based on this data, like, do we come up with Mahadasha calculations as well? Does that get factored in for calculating like 19 years for Saturn and all those things?
I have not gone into that.
Not really, Nitika. Actually, because if it is so, then Venus should have lesser time period, right? Because Venus takes only 18 days, right, for 30-degree movement. But actually, in astrology Mahadasha, Venus is the maximum, right, 20 years more than Saturn.
Okay.
So logically, it is not that way. Maybe that could be due to a different reason.
Okay.
Yeah, so we are
That's
not
very interesting.
100% sure why it is that way. Yeah. So basically, area to study further in this one.
Yeah.
So that is the only thing that so even though the distance that it needs to cover is also high, because it's rotating at a very revolving at a very slow speed. It takes almost 2.5 years for the Saturn to move from one house to the next. And if you see Jupiter, it takes almost a year. So this is closer to what we are also using. So for Guru to move from one Rashi to the other, it takes almost 1 year.
Right. Yeah.
So this is something which I wanted to kind of pictorially see, like how the retrospective motion kind of happens. So if you see, this is the Earth, this is the Sun, and this is the Saturn. And this is the celestial sphere that we are looking at. So this is where the constellations are. So if you see from the Earth, we see that Sun is in the celestial sphere. So we can see that it is in the first quadrant. And the Saturn, if you see from the Earth, is in the seventh quadrant. So in the Rashi, you can say that the seventh house is in the first, Sun is in the first house. So when we see that the Earth kind of goes in 30 degrees movement, we see that the Sun kind of moves from the first house to the second house. Because the Earth moves 30 degrees, we see that we move the Sun from the first house to the second house. Because we are seeing from the Earth, and the Sun seems to be moving from first house to the second house. Whereas if you see the arrow on the Saturn, the line actually goes backwards. So the slope of the line from this chart is actually tilting in the backward direction. And this happens because the Saturn is not moving very slowly, and it's almost moving 1 degree for every 30 degree the Earth moves. So if the Earth moves from here to here, the Saturn moves 1 degree. So it's not an appreciable change in the location of the Saturn, whereas the Earth has significantly moved in its orbit. And because of that, the slope of the line goes in the backward direction. So we see that in this constellation, the Saturn looks as if like it is going in the reverse direction, because we always reference it based on the celestial sphere. So the Earth going around its orbit and the Saturn not moving in its axis significantly kind of gives us an illusion that the planet is moving in the reverse direction. But actually it's moving in 1 degree in the forward direction, but for us it looks like it's moving in the reverse direction.
Right. Perfect.
So if you see going to the next thing, so this is where the Earth starts going to the maximum point, where it is on the horizontal point of the axis to the Sun, and the Sun is in the third house, and then it has almost crossed 90 degrees, but still the Saturn has moved only 3 degrees. So this is the point where the retrograde tends to kind of slow down, and the line kind of reaches the maximum slope. And after this, the Sun reaches the point where the Earth reaches the maximum angle. And this is the point where we see that the slope of the line is the most negative. But if you go next few more points, we see that the Sun and the Saturn are all in the same house. And if you see the slope, it kind of goes back to the point where it started. So we see that the retrograde motion actually kind of now is complete. And now if the Earth moves to the next quadrant, we see that the Saturn will be moving in the forward direction. So this is the place where from here to here, we see that the retrograde motion of the planet is taking place. But actually it's moving slower, and we get this illusion of planet moving in the backward direction.
Right. Yeah.
So then we have another movement of the Earth. So we get it in 10th house. Then again it goes back to the first house. Then for 1 full degree, this Saturn has moved 12 degrees. For 1 full rotation of 1 full revolution of the Earth. So once it goes to the next 1 year, so then after 2.5 years, when it comes to the same point, then we see that Saturn has finally reached the 8th house. So it takes almost 2.5 years to travel from this point to this point, and it almost takes 30 years to come to the same point in its chart. So that is the Saturn's revolution. So Saturn in our horoscope takes 30 years to come to the same point where it started. Any questions? I think that is all I have.
Thank you. It was really good, the presentation. Thank you so much.
Yeah.
Good one, sir.
Thank
A
you.
very good one.
Thank you.
Yeah, any questions, guys?
One question on the last three slides, actually.
Mhm.
You can just open up. Yeah. So this 1, 2, 3 you're showing, right?
Mhm.
These are actually houses.
Yes.
Okay. So when you say that from the Earth's point of view, let's say that I look at the sun.
Mhm.
So when I'm in the first house, the next movement of the sun should be the 12th, isn't it?
No, see, the Earth is rotating in this direction, right? So it
Yeah.
kind of goes in the opposite direction. So I'm here. So Earth moves from here to here. The sun goes from 1 to 2.
No, sun. How will sun go from 1 to 2? It should be the
So
opposite direction, right?
I am seeing from here.
Hmm.
So on the image I see is placed on this celestial sphere. It's like I'm taking a photo from here. So when I take a photo from here of the sun, I see one and sun together.
No, what I meant is, let's say at morning. Okay, what is sunrise time? So let's say sunrise
This
time
is
is
not morning.
6:30. I'm sorry.
No, this is not rotation of the Earth. This is a revolution.
Okay, revolution. Okay, fine. Even then, revolution. I understand.
Yeah.
Okay, that changes the perspective.
So what Vikram is saying is based on the self-revolution, right? In the day, you can see that sun is moving from Lagna point of view. It may be moving 10, yeah, like that it will move.
Yeah.
But for each day, the Earth moves 1 degree around the sun, right? So with respect that at the end of 30th day, you will see the sun is moving to the next sign itself, right?
Correct. So, so how he's looking at this, he's considering 1 as Aries, 2 as Taurus in that way. Correct.
Right.
Yeah. That's the perspective. Correct.
Yeah. So so every day rotation of the sun, Earth, we still see the sun in the same Rashi.
Yeah, that's correct. So which means the way we should have put this slide is like probably you can say 1 is Aries, 2 is Taurus, 3 is this way. So every day, today we are in 30th of Jan. So ideally we are in Capri, right? So somewhere near Capri is where we are standing right now. And the next position of the sun would be towards Aquarius.
Right. That is after 30 days.
After 30 days, correct.
Yeah. So it happens every 30 days. So every 30 days, the Earth moves from one quadrant to the next. Then the way we see the sun moving, sun actually doesn't move. So it's the Earth which is moving. So we see that the sun has moved from one quadrant to the other.
Correct. What the point I want to make is this 1 to 12 here in this slide would represent them as signs or rasis, whereas if I look at them as houses, then the actual perspective changes from a day's point of view. Because morning sunrise, if I'm at sunrise in the morning, sun would ideally be on the first house, right? Okay, and then
sun will always be in the first house. Sun will not change based on the day rotation. Sun will not change. Sun will always be in the first house. It's only the Rasi, the constellation which is rising on the easternmost horizon, that will change. The sun will always be on the same Rasi.
For 30 days, right?
For 30 days, correct.
Yeah, then it will change. So maybe if we put it clockwise, would that make more sense? I mean, is that why the confusion is that like instead of 10, 11, 10, it should be 1, 2, 3, 4, that clockwise?
No, Nitika. See, sun at any point in time will be on a particular sign, right? So today I'm on 30th of Jan, so which means I am somewhere midway of Capricorn, midway, because Jan 15th to Feb 15th I'm in Capricorn, right? So I am somewhere midway of Capricorn today if I look at Sun's position in the sky, right? Now, what I'm asking is, let's say if I am, and if the time today is say 8:28 IST in the morning, so 2 hours after sunrise. So I would say Sun is in the 12th house, but in Capricorn. That's the perspective.
No. Sun will still be in the same star, whereas the Lagna will be different. Lagna is the constellation which is rising on the easternmost horizon when the time is calculated. So when at a particular time, what is the easternmost horizon? What is the constellation? So that is your Lagna. The Sun will always be in the same thing. So you are rotating the Earth, but the Sun's location still remains the same.
So if are you saying that if I cast a chart today at this point in time, 8:30 a.m. in the morning, are you saying Sun will be in the first house?
No, you guys are. I think you guys are saying the same thing. Mani is saying the Lagna will change, and Vikram is saying Sun will be in the 12th. So it's the same thing.
That's right. Yeah, exactly.
Yeah,
that's
correct.
right. It's basically the viewpoint. Actually, see this wheel. What Mani put it is right. It is basically a zodiac sign.
That's right.
You have to look at it in a zodiac sign.
Correct.
So, but every 2 hours, due to the self-revolution of the Earth, the Lagna is changing. Because of that, you may see Sun moving to a different bhava. Okay?
Correct. That's what I was trying to say.
But still, for 30
Sun
days,
will
the
not
Sun will
move
be the
to a
same.
bhava.
Not move, right? I think the rotation of the Earth is reflected by the movement of the Lagna.
Exactly.
The rotation of the Earth around the Sun is reflected by the Sun's movement in the chart.
Correct.
Okay.
So Sun will not move like one. It moves like 1 day 1 degree, right?
Right.
So in the zodiac, Sun will move 1 degree, whether it's a 12th house or is depend on the Lagna. Lagna will change to like every 2.5 hours. Lagna will change. So if you talk it with respect to Lagna, then the 12th house like that it will change. But when we talk about this, we should not talk about the Lagna. We are talking about only the Rasi. So we have to take out the Lagna from this concept. Then it's easier to understand.
Okay. No, because I got confused when we said that the 1 to 12 are houses, but they're not houses, they're signs actually.
Yeah, their signs is the zodiac. Yeah.
This is zodiac signs.
Yeah.
One question from me. Mani, you explained that the retrograde takes place for 6 months, right?
Yeah.
I don't think it's for 6 months. It should be like 4 to 5 months.
It depends on the location of the like. See this. It happens from here to here is 2.5 years, right? So if I start from here, then it may take say 6 months. Whereas if I start from here and the planet is in a different location, then it may be different. So,
okay, you can cast a chart and see and change the month. You can see that the retrograde, for example, in your chart, the retrograde is not marked at all. So if you like, just look at the chart, the Sun and the Saturn is opposite. You can directly say the Saturn is retrograde. So if the retrograde happens only when the Sun and the planet is in the opposite houses or opposite rasis. So the retrograde will start when the Sun enters like 7 minus 2 houses. That means 4th or 5th house when it enters, then the retrograde will start. So after 7 plus 2, then retrograde will end. So within the 2.5 years of Saturn, the retrograde will happen once in a year. So like when the Sun goes opposite to the Saturn, then the retrograde will happen once. So every year Saturn will retrograde for like 4 months. So it will never be 6 months.
That's right. I think when Sun and Saturn are opposite, the retrogression will be at the peak, I guess. So it ideally starts before 2 months, and it'll be in the peak when they're in opposition, and it will relieve after 2 months.
Yeah, that's correct. Yeah.
But I think this rule is apply only for the outer planets, right, Kumar?
Yeah. Retrograde is only for the outer planets. Yeah. The retrograde for Sun, Mercury and Venus will, if you see the chart, Mercury and Venus will be going 2 and 4 across Sun. So so that's what in your geocentric model, you should not represent the Venus movement as around the Earth. What you have to do is you have to put Sun and then put two circles around the Sun. So that's much easier to understand. Like if you look at the horoscope, right? If you keep changing the months, the Mercury and Venus will be going to and fro. So Mercury will be going in a shorter to and forth. Venus will be going in a longer to and forth. So like Mercury will always go only one house ahead of Sun and one house behind of Sun. Venus will go like two house ahead of Sun. So based on this, you can directly say that the orbit of Venus is longer than the orbit of Mercury. So yeah.
So this is what is shown here, right? Because it gives an illusion that these planets are revolving around the
I understand that this will give a correct astronomical reading, but if you want to understand it clearly, like you can put the Venus and the Mercury circles around Sun, so it's easier to visualize. You get what I mean?
Yeah, like we want to put these two lines into the same line as the Sun, and then have this one.
Yes, correct. Yeah, then the Mercury will be a smaller circle, Venus will be a bigger circle.
Yeah, so all these are, if you superimpose these three lines together,
yes.
It will, from the other point of view, if you see, this will actually go to and fro between the light from the Sun.
Correct, exactly. Yeah. So because if you put this circle, there is no physics that can explain that the planet cannot go like circle, then also revolve around another center of thing, right? So it's much.
No. This is to show that the retrospective motion. So if you see from here, there is no retrospective for a moon, or there is no retrospective for Sun. Whereas the Venus, even Mercury, it will show sometimes that it is going backwards because it's on the retrospective.
Yeah, Mani, but this does not show that the Mercury and Venus will always be closer to the Sun. It's not reflected in this picture. If you put that circles around the Sun, then it is easy to understand that Mercury will always be closer to the Sun.
Yeah.
You understand what I mean? If in a chart, Mercury will always be one house ahead or behind.
That is not reflected. The only thing is that when you move this thing, so this is all these three are kind of tied up together. You can say that, like if this moves, then automatically this moves, then automatically this one will move.
Yeah.
You see that these three are like tied up and move in connection.
Yeah. Yes. So that's one thing. Then, one point I was very interested is in your graph where you show the pattern of the lunar and solar eclipse, right? That was quite new to me. It's very interesting. And why lunar eclipse is happening more consistently, which I'm just trying to reason, is because the shadow of the Earth is bigger than the shadow of moon on.
Yes.
Yeah. So
that's the reason
the shadow of Earth on Moon is bigger than the shadow of Moon on Earth. So that's why I think we are getting a more frequent lunar eclipse compared to frequent total solar eclipse.
Yeah, it's like a big hitting a target which is bigger, so you'll be able to hit it easily. Whereas if you want to hit a smaller target, then you have to be very precise.
Yeah. And I did not see the point where maybe I missed. You did not mention anywhere that why the anybody can answer. If you look at from the Earth, which looks bigger, Moon or Sun?
Yeah, so
it's the same, right? Because of the distance.
It's my favorite question to everyone. So you forget about astronomy. Just you are on Earth. You are seeing the Sun. You are seeing the Moon every day. Which looks bigger to your eyes?
It's the same because of the distance.
Yes, correct. Yeah, it's the same. The proof is a total solar eclipse. So when the total solar eclipse happens, the moon is exactly superimposed on the sun. So that means when you see relatively, it is exactly the same. So that is because you can, like what you're explaining is because of the distance and the size, the ratios.
Yeah, exactly. Yeah.
Yeah, correct.
I have a question. I'm still confused on the partial eclipse and full eclipse. I'm not sure how the partial works.
So basically, if it is on this side, like this is like a total solar eclipse, but if it is not able to kind of hit that portion, these people outside the particular zone will be still seeing the eclipse, but on a partial side. Like it's not fully covering the sun, but still it kind of crosses the path of the earth where if you see the moon, if from the earth point of view, if we can still see the sun and the moon, then the shadow of the moon slightly touching the earth, but it's only the periphery which is kind of touching the earth, then we still get a partial solar eclipse. Like there is a core shadow, which is a total solar eclipse, and there is a kind of concentric circle where the outside circle still experiences a partial solar eclipse, whereas the center core experiences the total solar eclipse. So when the center core doesn't hit the earth, whereas the partial the shadow hits the earth, then we get the partial solar eclipse. It's like even when we have a total solar eclipse which is directly hitting the earth, not every region will have a total solar eclipse. So the point at the center of the shadow is where you get the total solar eclipse. The point, say 200 kilometers from the center of the earth, from the center of the shadow, will still see an eclipse, but it will not be a total solar. So it will be a partial solar eclipse for them.
When it's partial, are we still aligned on the line of nodes?
It will be aligned on the nodes, but the only thing is that the full it will not be an exact alignment.
Okay.
It will be
Yeah,
like
probably the place from where you are looking at it, right? These nodes may not be aligned because the Earth itself is a bigger object. You may look at the eclipse at different point in the Earth, right? So at some point in the Earth where the line is exactly aligned, you will be witnessing the total eclipse. But whereas if you are in a different part of the Earth where your line of node is not exactly aligned, you will still see the eclipse, but it is partial for you.
So are we saying that we always have full and partial?
Yes.
Yes, that's right.
Okay. I thought it was different.
So if you see the moon here, if it is just before it touching the node, it will still be covering some portion of the sun, right?
Yes.
So, and that shadow will be still hitting the earth.
Yeah.
So in that case, if that way you will still see the sun and the moon covering the earth, but moon covering the sun, but not the entire sun. But still it is closer to the node and still not covering the sun. So it becomes a partial solar eclipse.
Colin, every year you have something called annular solar eclipse. Annular, right? So the annular solar eclipse is where you don't have that diamond ring effect, where the moon does not totally superimpose the sun. Okay. Whereas in the partial solar eclipse, you always have the moon covering at least some part of the sun, like what Mani just explained. So the biggest phenomenon is always the total solar eclipse, which comes at some point in time, but not every year.
So that is where exactly it will match the line
of sun.
Will be the like sun, moon, and earth will be exactly on the same line. So 1 or 2 degrees here and there, you will not get a full solar eclipse. So
another point is the total solar eclipse is when the moon is closest to the sun, to the earth, right?
Not necessarily.
Yeah.
No, sorry.
Not necessarily.
No. And why I'm saying is because if it has to superimpose, the moon will be kind of closest to the Earth, whereas in an annular solar eclipse, the
No,
moon
it's
will
not
just cover
necessary.
the sun to the extent from the ring.
Even if it is on the other side also, like large furthest from the sun, still it will be able to cover if it aligns exactly with the sun. But the only problem where we get a partial solar eclipse is it is not exactly 0 degree, whereas it is just plus or minus 1 or 2 degrees or 3 degrees from the line of node. And still, because Earth, the sun, moon is also moving, right? And Earth is also moving. So we need to come to a point where exactly the Earth movement and the moon movement and the sun is on the same point. So that is where we don't get a regular solar eclipse. So we get a partial solar eclipse and moon is plus or minus 2 degrees from the node, which is not become a total solar eclipse, but still become a partial solar eclipse.
Yeah, partial in the sense still sun is not fully covered.
Sun is not fully covered, correct.
Okay.
In the data you collected, are they all like full, complete?
Yeah, all full solar.
And in terms of astrology, when we have the full, it's generally a bad thing, right? Or how do we interpret that? It's bad, right?
Mundane astrology, it is considered as a bad,
Okay.
Especially if we have other combinations like Saturn Mars conjunction, retrogradation. So those things are considered as something evil for the entire world.
So because we're not considering the partial in your data, I'm just wondering if there's still a trend, or
Yeah, that's why I wanted to kind of, if I keep the partial also in between, then I'm not seeing a trend.
Okay.
So I want to make sure that at least we kind of look at a total solar eclipse. So at least we will be able to find a trend. Because annual solar eclipse means every year you will get one.
Yeah.
So then it becomes
that's why the annual, the 365 and 355 is almost same. So it cannot be less than 355, right? Even though like 2 times a year, so it's like 355 is close to the 1 year.
Yeah, so there is a possibility of the total solar eclipse when the Earth is kind of one revolution around the soul. It's kinds of 2 times you have the possibility, but very rarely you will get 2. So you will not get a 2 in a year.
Okay. Thank you so much.
Okay, Mani. Thank you. Great efforts, Mani.
Yeah.
Thanks for all your effort. Any other questions before we close?
Can you go to the earlier slide where you describe the seasons?
Okay, seasons. Okay.
But the seasons is based on the inclination of the Earth, right? Not the distance from the.
No. This is the inclination is shown here. So the axis is tilted towards the sun. So then this year, if you see July, the northern is kind of hemisphere will be facing the sun.
Sorry, I didn't see the inclination in your. When I see earlier, I didn't see the inclination. Okay.
Yeah. So even the distance will also play because you see the northern hemisphere, the sun is kind of further away from the Earth is further away from the sun. So the intensity of the summer in northern hemisphere will not be so high, whereas if you see the intensity of the southern hemisphere summer is very high because it should be closer to the sun.
Okay.
So it is 152 million kilometers further. So here it is only 147 million kilometers. So the southern hemisphere, if it's like right now, Australia is experiencing summer. So this summer will be more hotter than the one that is experienced in northern hemisphere.
But this picture, is it to scale?
No, just a
Okay.
These are all Wikipedia, so I just took it on vacation. I keep on looking at all the data and then I just grab when I see interesting data.
Money. There's not much difference between 147 and 152 million. Like, is there?
Yeah, not much difference. So it's not.
But it looks like
not
the scale looks like it's like almost
Big,
like double of what you're showing there.
Yeah, but still, as a kind of how many million? So it's almost 5 million kilometers.
Yeah, but if you take the percentage, then it's not that big of a difference. What, 5? Right?
The angle of the plane, I think.
Yeah.
This is that's what. So it's a matter of relativity. Yeah.
But seriously, this is great effort, great work. Thank you, Mani.
Yeah, sure.
It's very knowledgeable. Thank you so much, Mani.
Yeah, curious to looking at the sky and getting curious. So just grab whatever data you see and then keep on adding to that. Yeah.
No, thanks for sharing this. It's wonderful.
Yeah.
When did you start, actually?
I started with this, and then I started learning astrology with Muthu. So almost 3 years, 2 years maybe. Yeah.
So Mani started with astronomy, then came to astrology, like Rishish, like our Rishish.
That's the perfect way, actually. Yeah, that's great. I have to go backwards now.
I'm always kind of interested to know like how our ancestors were able to kind of predict all these things. Even Navagrahas, how they were able to put the sun in the center and all the planets rotating around it. Then even like so further down the line, they are still arguing that sun is rotating around the Earth. So it's quite interesting.
Any other final thoughts? Anybody?
Few things like other interesting questions I have in mind, which I am also looking for answers, is why the zodiac is fixed compared to when we observe from Earth.
Because it's made of stars, right? So the stars are very farther away. So any movement of the Earth will not be a significant movement of the stars.
Okay, that's fine, but it has been fixed over thousands of years. Another question is, the stars that we see in the zodiac, is it all within the Milky Way or outside the Milky Way?
Should be within the Milky Way. I think so.
I mean, I just tried to Google, I couldn't find, but I think should be within the Milky Way. Otherwise, we will not be able to see. If you see how the whole Milky Way rotates, it doesn't. There's no relative movement. The whole Milky Way flies through the universe as a one single unit of or the cluster of objects. So if you see like solar system, right, like sun is between, all planets are moving relative to each other, right? But if you take the Milky Way and you have all the stars, the whole Milky Way is like rotating like a disk as a thing. So that's why, I mean, I understand that the zodiac is fixed. So it is the whole zodiac is moving as one unit. It's not stationary, but it is moving through space as a one single unit.
Okay. So as we move like along with the Milky Way, the zodiac is also moving. So relatively, it means
yeah, I think there's no relative movement between the stars. It's just moving as one group.
Right. Yeah, I still see that the stars are the like reference point for us to mark the position. Even for one thing, I was just trying to understand, like why did they choose Sun to be moved to Aries as a first point? It can be any other point, right? But what I see, right, when Sun moves to Aries in the same month, obviously the Moon will move to Chitra Nakshatra, because Chitra is the one of the brightest star. I think compared to the Moon's position in any other star, to mark it in the Chitra will be much easier because it is the brightest star. So I think that could be one reason why they chosen Chitra, and they call it as a Chitra month, Chaitra month. So when moon have the full moon on Chaitra month, obviously the sun will shortly move to the Aries. So that could be the easier way to market the sun's position.
Oh, that's a good point. Yeah, you're talking about Chitra Paurnami, right? The Paurnami coming in Chitra.
Exactly. In the Chitra month, the Paurnami comes, right? That's
it's one of the auspicious full moon, right?
Yeah, because that marks the start of the year, because simultaneously the same month sun moves to the Aries. Because if you take any other nakshatra, it is very difficult to find actually. The sun can move to Taurus, anything, right? But when moon moves to the Chitra Paurnami, then that month the sun moves to the Aries. So that is easier to fix it actually.
And that's what Muthu, I think I see that you can't directly see the stars when the sun is there. So there will not be any correlation between the sun and the stars. So there should be a correlation between moon and the star, and based on that, the sun will be positioned.
Exactly, that's right. Because I was trying to understand how they come to the conclusion Aries first point Ashwini. Because when sun is there, we cannot see Ashwini, obviously, right? So then only I came to, okay, I just thought about it. Okay, it could be because of moon position in the Chitra. And that's the time when sun moves to the Aries.
So I always see that the nakshatra is the kind of starting point where we start looking at the star and then get the moon position, and that becomes the Rasi. And then we kind of see how much duration from the day the sun has started, and then we plot the Lagna. So Lagna and there's a unique combination between the sun and the moon positions. So
probably like one more maybe a kind of action item what we all can take is like trying to split the entire earth into different regions. I think that way we will be able to predict much more on the mundane side. Because in ancient time also, the Ujjaini is taken as a center point for India, right? On what basis it is taken, that we need to still understand.
Yeah, it is here, Muthu. Think here. This is the Ujjain Mahakaleshwar temple, where the zero latitude meets the Tropic of Cancer.
Okay.
So that's why it's called as a.
So that's why it is called as meridian. Okay. I think something we need to do like more on that area. Like I'm an ancient, right? If you read this Brihit Shanmita, like different regions are given. Different parts of the earth is given as a different regions. Based on that, if particular eclipse happened in this particular region, then these countries will suffer. All those things they have written. So there should be some logic behind that actually. So the entire earth, they might have divided into different sections. So based on certain planetary focus on that particular area, certain sinisters are actually predicted. So those things are also we need to understand. But it's a good start, Mani. It's a very good start. You have given a lot of information today.
Yeah.
Great to know.
Thank you.